All right, now you might get a misleading impression from what I just presented there because I did this sort of odd trick that's not really very kosher. Specifically, when I gave the example of a teacher asking questions to lead the learner to a particular hypothesis, I allowed the teacher to ask any possible question in the universe of possible questions, right? So the teacher could construct a question, and in this particular case, that specifically had a yes answer for the target hypothesis and a no answer everywhere else. And that just simply doesn't happen in any realistic learning question. So we need to think a little bit more about the question of what happens when the teacher is constrained with respect to the kinds of queries that it can suggest. So I'm gonna set up classic computational learning theory hypothesis class, and we'll go through some examples about what happens when the teacher is constrained in this way. So let's imagine that our input space is basically k-bit inputs, so x1 through xk, and the hypothesis class and literals or their negation. So here's a concrete example. Here's a hypothesis that is in this set. X1 and X3 and not X5. We're going to connect together some of these variables, not necessarily all of them, and some of them can be negated, and it's all the connectors have to be ands. All right, so Charles, let's make sure that that you understand this. So let's look at some inputs. All right, so let's say our input is this. X1 is 0, X2 is 1, X3 is 0, X4 is 1, X5 is 1. What is this formula going to evaluate in this case?
Okay, so 0 is false and 1 is true, I assume, because that's what we do in these things. X2 and X4 don't matter. I just have to look at X1, X3, and X5. So X1 had better be true, and it isn't, so I already know the answer.
It's false. Very good. All right, let's try a couple more of these.
Okay, so I would do the same thing I did before. I would look at X1, X3, and X5. So in this case, X1, cleverly I've noticed, is 1. So that doesn't give me the answer right away because you're an evil teacher. X3 is also 1, but X5 is 1, and according to the hypothesis, it has to be 0 for this to be true. So 0. I can do the same kind of thing for the third line. So X1 is true, like it needs to be, but X3 is false instead of being true, so also 0. And then in the bottom, let's see, X1 is true, which it needs to be, X3 is true, which it needs to be, and X5 is false, which it needs to be, so the output is 1.
Very good.
All right, I got it.